Hey guys, Miss Farian here. Welcome to Unit 7, Note 6. We're going to look at mutually exclusive and inclusive events today. So yesterday we talked about independent versus dependent, and we said those were our and probabilities. We saw the word and I told you that and tells me I multiply. So today, when we're talking about mutually exclusive and inclusive, we are actually going to call these our or probabilities. These are when you see the word or, and that tells me I'm going to add and subtract. So today we're not going to multiply, we're going to add and subtract. So if it was an and problem, we'd multiply. If it's an or problem, we're going to add and subtract. So let's look at this first example here. I have a bag that contains 8 red M&Ms, 8 red marbles, 12 blue marbles, 9 yellow marbles, and 11 green marbles. A marble is drawn at random. Find the probability that the marble drawn is either a blue or a green. So we're going to look at it as we want to make sure that I am happy, and I'm only going to be happy if I have a blue or a green. So we're going to find the probability of having a blue. So probability of a blue marble is 12. And I could get a green as well. Probability of a green marble is 11. So total, there are going to be 23 marbles that would make me happy. So if I'm creating a probability out of this, I would do the ones that would make me happy out of the total amount there. So when I do 12 plus 8 plus 9 plus 11, I get 40 total marbles. And then in my calculator, I would divide those and I would get 0.575. So, like I stated, today we're going to look at mutually exclusive and inclusive events, and that's when we're adding probabilities. Mutually exclusive means that they do not affect each other. So basically rolling a 5 and then flipping a tails, neither one of those affect each other. I can't both roll a 5 and flip a tails at the same time. So then I'm going to find the probability of one and add the probability of the other and be done. Inclusive events are when they do affect each other, when there's some overlap going on. So if I were to roll a number less than 3 or a 1, well, a 1 is a number less than 3, so I counted that twice. So I have to go ahead and subtract the overlap, the and part. So for these problems, when you see the word or, we're going to add or subtract, and you just have to determine, is it an exclusive where they don't depend on each other or they don't affect each other, or is it an inclusive where they do affect each other? So let's start by just trying to determine which it is, exclusive or inclusive. So these all have the word or, which tells me I know that I would be adding these if I was going to actually solve them. Now, the way that I look at these, number 1, drawing a heart or a diamond from a standard deck of cards. I look at it and I go, can I be a heart and a diamond at the same time? If I cannot be a heart and a diamond at the same time, then there is no overlap, so these would be exclusive. They do not affect each other. Number 2, drawing an ace or a spade from a standard deck of cards. Well, if I'm thinking of my deck of cards, I have the ace of diamonds, I have the ace of hearts, I have the ace of spades, ooh, I'm not an art teacher, and I have the ace of clubs. Okay, so I can be an ace and a spade. I have that right there. So since I can be both of them at the same time, that is an inclusive. They do affect each other. So now, can I roll a 5 and be a number greater than 3? So if I'm thinking of my numbers greater than 3, I get 4 and 5. So I can do both 5 and greater than 3. So these are inclusive. Number 4, picking a red or a blue M&M out of a bag. Can I be a red and a blue M&M at the same time? In this situation, no, I cannot be a red and a blue M&M at the same time, so these are exclusive. They do not affect each other. So let's look at some examples here. Number 5, I have 1 teacher must be chosen to supervise a senior class fundraiser. There are 12 math teachers, 9 language arts teachers, 8 social studies teachers, and 10 science teachers. If the teacher is chosen at random, what is the probability the teacher is a language arts teacher or a social studies teacher? So or tells me I'm going to add, and here's how I'm going to look at this. I'm going to find the probability of the first thing, so probability of A, or in this situation, probability of a language arts teacher. And I'm going to add the probability of a social studies teacher, and then I'm going to subtract the probability of being both. Okay? So I'm going to look at this and I'm going to say, well, can I be both a language arts teacher and a social studies teacher? We know that not always that happens. More than likely that doesn't happen. So in this situation, I don't have any language arts teachers that are also social studies teachers. So I don't have a both in this problem. So I know that I'm dealing with a mutually exclusive problem. So I'm just going to find the probability of a language arts teacher. Well, I have 9 language arts teachers. And then total, I would have 39 teachers. And I'm going to add the probability of a social studies teacher. So social studies teachers, I have 8 out of 39. And since we're not subtracting them both, I'm just going to do this problem here. Now, when you are doing this, you're going to add the top. So I'm going to do 9 plus 8. Well, I'm going to get 17. And your denominator stays the same, so you'd get 39. If I put this in my calculator, then 17 divided by 39, I end up getting 0.436. Remember, we want to round to that third decimal, or that third spot. So example number 6 here, suppose that out of 1,400 students, 150 take Spanish, 700 take biology, and 400 take both Spanish and biology. What is the probability that a student selected at random takes Spanish or biology? So I'm going to find Spanish, or tells me add and subtract biology. So I'm going to do the probability of Spanish. So probability of Spanish plus the probability of biology. And then we're going to subtract the probability of both. Okay, being both Spanish and biology. So I'm looking at this. Do I have, out of my 1,400 students, some that take both Spanish and biology? I do. I have 400 of them. So I am going to have a both in this situation, which tells me this is an inclusive event. So let's find the probability first of my Spanish. Well, I have 550 students out of 1,400 that take Spanish. I'm going to add my probability of biology. So I have 700 out of 1,400 that take biology. And then I'm going to subtract the both. Well, I have 400 that take both out of 1,400. So when I plug this in, I'm going to do 550 plus 700 minus 400. I get 850. My denominator is going to stay the same. And when I plug that in, I get 0.607. Example number 7, there are 2,400 subscribers on an internet service provider. Of these, 1,200 own HP computers, 500 own Dell, and 100 own both HP and Dell. What is the probability that a subscriber selected at random owns an HP or a Dell? So, or again, I'm adding and subtracting. So I'm going to do the probability of HP plus the probability of my Dell, and then minus the probability of both, having both. So I'm going to look at this example. Do I have an overlap? Do I have ones that have HP and Dell? I do. I have 100 people that have HP and Dell, so I do have a both in this situation, which means it's an inclusive. So probability of HP, I have 1,200 people that have HP out of 2,400 total. My Dell, I have 500 that are Dell out of 2,400 total. And I'm going to subtract the both. I have 100 out of 2,400 that have both of them. So 1,200 plus 500 minus 100 gives me 1,600 divided by 2,400. Divide that in your calculator, you should get 0.667. Example number 8 here, there are 4 algebra books, 3 literature books, and 2 biology books on a shelf. If a book is randomly selected, what's the probability of selecting a literature book or an algebra book? So I know that I'm going to do the probability of a literature plus the probability of algebra minus the probability of both. So I'm going to think to myself, can I be a literature book and an algebra book at the same time? I cannot. So there is not a both situation, and I'm going to be in mutually exclusive then. So I'm just going to do the probability of literature. So there are 3 literature books out of 9 total, plus the probability of my algebra book. There are 4 algebra books out of 9 total. And I don't have any subtraction, so I'm just going to add them. So I get 7 out of 9, which is going to give me 0.778. So now we are playing bingo, and in the game of bingo, balls are numbered 1 through 75. These numbers correspond to columns in a bingo card, as shown on the table. A number is selected at random. What is the probability that it is a multiple of 4, that should say of 4, or is in the O column? So I'm going to do the probability of a multiple of 4 plus the probability of the O column minus the probability of both. So I'm going to go ahead and I'm going to list out my multiples of 4 just so I know them. So I'm going to have 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72. My next one would be 76, but I don't have a 76 on my bingo card, so I'm going to stop there. So I'm going to say to myself, do I have a both situation here? Can I be a multiple of 4 and be in the O column? So O has 61 through 75. Well, I can. I have 3 different numbers that are in both. The 64, 68, and 67 are in my O column. So I do have a both, which means that this is a mutually inclusive problem. So I'm going to find the probability of a 4, just a multiple of 4. Well, when I did that and I listed all of them out, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 out of the entire bingo board, so 75. Now the probability of the O column, well, I have 61 through 75, so I have 15 out of 75 in the O column, and then subtract the ones in the both. So ones that would be in both are the 3 that we looked at, so I would have minus 3 out of 75. When I do 18 plus 15 minus 3, I get 30 out of 75, and that's going to give me 0.4. So for this last example, we have a card that is drawn from a standard deck of cards. What's the probability of drawing an ace or a face card? So we're going to do ace or a face card. So I want you to go ahead and pause the video, try this one on your own, and then come back and check your answer. So when I did it, I got 0.308 as my answer. There is no way that I could be an ace and a face card. So this is not a both situation, so I didn't have any subtraction to do. If you didn't understand that one or you got that one wrong, please come chat with me before moving on to your assignment.